right, shall we get started? So while people file in, I see the numbers increasing as we move forward. My name is Jim Edson, and I am the new principal investigator for the OOI, and I'm formally taking over the reins from John Trowbridge tomorrow on March 1st. And I thought this would be a really good opportunity to introduce myself to the community, so that give you a chance to see and meet me. And I just want to say I'm very excited about the opportunity I've been given to step into John's big shoes. And as such, I feel the need to thank John and also the Program Management Office and the IOs at Oregon State, University of Washington, and Woods Hole for handing me what is a well-oiled machine that is currently filling 25 million data requests per month. So I will continue to work with the POs and the Program Management Office and the implementing organizations just to improve the way that we acquire data and deliver it. And to do this, I will be reaching out to the scientific community, federal agencies, and of course the general public who pay for all this for your input. But I'm sure you haven't tuned in to hear me talk. And so what I'd like to do is get the program started at hand. And just to say that you'll be hearing a lot about this process, but the National Science Foundation, the Ocean Observatory's Facility Board, OOIFB, and the OOI program itself have put a lot of time and effort into getting community input into where we relocate the Pioneer Array. Now, this was part of the original plan, and the fact it was called Pioneer because we envisioned every 3 to 5 years, like pioneers, it would go to a new place on our ocean, on our coastal ocean. And as you know, it's been currently located on the Mid-Atlantic Bight, but off the southern New England shelf. And so NSF and the OOIFB held workshops in 2021, seeking community input about the best location to move this array that would allow us to continue basically investigating a broad range of interdisciplinary science questions. And as most of you know that are tuning in, but not all right, we'll learn this today, it was decided that we would move this to the southern Mid-Atlantic Bight. Let me just move up here, thank you. We'll continue to work on this project, but today we're going to be hearing some of the news where we flesh out the reasons why we chose that location. And so with that, I would like to it's my pleasure to introduce the other panelists here, starting with Lisa Clough, who is the section head of the NSF's Division of Ocean Sciences. She will lead off the discussion to update us on how we got to this point and the plans moving forward. Lisa will then turn over her talk to Al Plueddemann, who leads the OOI's coastal and global scale nodes that we're going to refer to as CGSN, which keeps the current Pioneer Array operational. And Al will be giving us a timeline of where things stand and some of the challenges that we need to overcome in this process for planning of the arrays in a robust environment. Remember, the ocean off of Cape Hatteras is often threatened and overrun by hurricanes and has certainly experienced its fair share of strong winter storms. So Al will then turn it over to Derek Buffitt, who is the program manager for CGSN. Derek's our nuts and bolts guy. He keeps things working, and he will be providing some insight into the technical considerations involved in ensuring the successful array at the successful operation of this array at this new location. So I will ask each presenter, you are able to ask questions between presentations, and we'd ask you just to use the raise your hand feature. During the presentations, feel free to enter questions into the chat, and we'll also attempt to answer those between questions, and then I'm going to stop now so that we have time at the end for additional questions. So take it away, Lisa.
Thank you very much, Jim, and a big welcome to you. We're excited to have you join the OOI team, but also a huge thanks to John. I think John is on the call, and really we just are so grateful to all of his leadership over the past 5 years at least, if we include the transition to OOI 2.0. So things really are in a great place. I'm happy to be here with you guys today. Thanks for taking the time to join us. As mentioned, I am the Ocean Section Head at NSF. My email is on there. Please reach out if you have any questions. Also want to acknowledge Bob Houtman, who couldn't be with us today, but Bob is a section head at NSF as well, and we've kind of been partners in crime on the NSF side of things for the last couple years. But we will hopefully have a new NSF OOI program director coming in to join the team sometime this summer. So that's a bit of an NSF update. Next slide, Darlene. I do want to put front and center. It is us that required the move. As Jim mentioned, way back when Pioneer was named Pioneer because it was going to be in the explorer mode of going out first, but it was intended to be relocatable. 3 years is certainly maybe a wee bit too aggressive to keep moving it. As you're going to hear from Al, there's a whole bunch that goes into the actual move process. And for those of you guys on the call that participated in the whole process, gosh, a huge amount of hard work went into getting the move location picked out and everything else. So we are looking at on the order of a minimum, or I should say, as frequently as 5 years, but I think a little bit longer than that is kind of the lessons we're learning going through this process for the first time. Um, as Jim also mentioned, Woods Hole is still the primary operator for the Pioneer Array. So even though she's going to be moving farther south, Hui is still the facility who is running the Pioneer Array. We put some additional requirements on things. We're not increasing the budget, so we're really locked into the core equipment components. There's a little bit of flex around there, as you're going to hear, and including some challenges or some changes to water depth. But I just wanted you guys to be aware of basically the operating conditions that NSF put before we went into the process. Okay, yep, good. You can move on, Darlene. So, again, I said huge thanks to the community for participating in the whole move process. I also want to say huge thanks to the facility board and the facility. There was a whole lot going on in the background to enable this pretty innovative process. In fact, we called it the Innovations Lab. NSF has worked with KNOW, no innovation, when we do things called ideas labs. But what we really wanted to do was have an iterative process that fostered innovation and really was a welcoming space for interdisciplinary approaches. So it wasn't a standard RFI, request for information, request for proposals. We really asked the community to step up, participate in a pretty intensive week-long process of exploring different locations, including staying where it was, for what we were going to do with the Pioneer Array in the future. And so that took place. Phase 1 Innovations Lab was actually just in March, so about a year ago. We announced the move location in April, and you've already heard that. So the Southern Mid-Atlantic Bight, so moving slightly farther south. And then in June, again, huge thanks to OOI, OOIFB, and all the participants, we had what we called the Phase 2 Innovation Lab, where we really started to optimize what we could deliver in an interdisciplinary manner with a cutting edge science in the new chosen location. So again, huge thanks to everybody. There was a ton of hard work that went into getting us to that stage, and there's been a ton of hard work that has been continuing and will continue until we have the array in its new location. But it's still delivering awesome science in its current location. So I don't want to have you guys think, oh, we're already done. Nope, she's still delivering amazing things. So next slide. And on those amazing things, right? I just again with the pandemic, the challenges of delivering open science, which are significant, but I think the payoffs we saw during the pandemic have also been huge, right? We live on a very dynamic planet, but by having the open science commitment from everyone, getting folks out to keep the moorings, the gliders, the AUVs going, but having that information be available for everyone to use has just really paid off on the contributions to crises. And OOI, the community use of OOI really is in the space that we want to be in with turning that knowledge into action. And as we've been hearing, the oceans are having a moment. So the OOI observations are very much contributing to some really high level challenges for the entire globe, including the current ongoing UN Decade of Ocean Science for Sustainable Development. So last slide, can't say it enough. Huge thanks to all players. Super special thanks to John. And I would like to turn it over now to Al to really do the updates on the important things and be forward looking. Thanks.
Thanks, Lisa. Let me share my screen. How does that look? All right.
Great.
Thanks. Hopefully you're seeing that. So myself and Derek Buffitt contributed a lot to this presentation. A lot of the work behind the scenes is from Derek, but I'm going to just go ahead and give the whole talk today. So you won't hear from Derek directly, but he's available for the way this works is I give the talk, and then if there's difficult questions, I just pass it over to Derek. So that's how that works. See if I can go to the next slide. So Lisa talked about the first few things here. Let me just jump right down to the last bullet. The OI program started the relocation planning in July 2021, right after the completion of that last or second innovations lab. So we've started the process there. I want to give you a sense of the big picture here, kind of the look ahead. This is going to be a long process. We're actually in it right now. And it's going to be in 3 main phases. So phase 1, which started in July, as I noted, was really kind of the planning phase. We need to review and assess a lot of materials. We'll then go into an engineering/design phase, where we're going to be doing looking at mooring designs in particular, but other design elements, the site details, instrumentation requirements, things like that. And finally, by a little under a year from now, January 2023, we expect to move into implementation, where we would actually be procuring equipment, doing builds of new moorings, looking for regulatory approvals, and that sort of thing. So currently, we're in here in the planning phase, about 2/3 of the way through. In order to have the budget for and the time to do this relocation process, there's going to be a hiatus in the actual field implementation of the Pioneer Array. So the New England Shelf Pioneer Array is going to end in fall of this year. There'll be a recovery cruise and won't be redeployed. And then the Southern MAB Pioneer will start up in the spring of 2024. So the way we manage this with no new budget is to apply some of the funds that would have been going to field operations towards the relocation activities and replanning, refurbishing, procurement, and building. So a detailed timeline and workflow have been developed, and they're kind of behind the scenes. Derek is the architect of most of that. This is already, too complex for me to go through here, but it's a summary or a distillation of that more detailed plan. So just to assure you that there is a lot of detail going into this, but let me just tell you a few things about this. I don't want to go through this box by box, but I just want to make really two main points from this. First of all, the input to this workflow that we're executing comes from the Innovations Lab. That's our guidance, that's the driver, the science themes, the location, mobile asset operations, instrumentation, et cetera, are driven by Innovations Lab. We're implementing their recommendations. The second one is to look at these three kind of milestones here. At the end of phase 1, we expect to have a preliminary design. Midway through phase 2, there'll be an intermediate design that will be hopefully nearly implementable. And then by the end of phase 2, we'll be at a point where we have a final design that's ready for implementation. And at those 3 phases is where we will have an opportunity for some documentation and presentation of the status and some input, feedback from the community. We have a variety of methods for that, such as the program itself, the Program Management Office, the Ocean OOI Facilities Board, OOIFB, which was mentioned, NSF, the Program Management Team, and also we have established a focus group of community people, which I'll talk about in just a minute, that's going to help us through this. So I'm going to review a little bit about where we are in this planning phase, a little bit of the status, and give you some detail on some of the areas that are hopefully the ones of more interest to you. So first, let me run through the kind of, I don't know, I decided this was a baker's half dozen. There's seven main elements here of the planning phase, and I'll just run through those quickly, give you a sense of where we're at, what we've accomplished, and where we're going. So I talked about the focus group. This is an interdisciplinary group of people, many of whom were at the Innovations Lab workshops. They're knowledgeable about OOI, and they're familiar with the process. They are going to be able to give us feedback, as I talked about, at these different kind of milestone phases. I'm also intending to lean on them a little bit to answer some thorny questions that I can't figure out myself, or that we can't figure out as a team. It's a volunteer group. It's an ad hoc group. I don't want to tax them too heavily, but they will be providing some input. One of the biggest chores for us and what we've been working on and are still involved in, although we're near the end, is to consolidate the Innovations Lab input. We went at it with the exact same sort of construct that was used in the labs themselves, and that is to talk about the science themes, the array design, the instrumentation, and the use of mobile assets. The science topics were voluminous. We got hundreds of them from the Innovations Lab, which were really great, but they also were prioritized by the participants, which was fantastic. So we were able to kind of take the high level or high priority themes and group them. And I'll tell you what those groups are in a couple slides. The Innovations Lab also did a really nice job of creating a kind of consensus region, as well as a rough consensus first draft moored array design. And we're using that we use that to kick off our what we might call the implementable design, just has to accommodate some other constraints. And then we have also a lot of information about desired instrumentation. And I'll talk about that in a subsequent slide as well. We've kind of gone through a first draft, at least, of the what might be realizable. The mobile assets, in terms of where the collider track lines will be and such, has not really been addressed yet. So we're not to that stage. In order to operate in this area and design moorings that are going to work, we need to understand the environment. We're involved in what we call a site characterization. We started out with looking at waves and currents. Those are the most critical for the mooring designs. And we're going to move into things like bathymetry, bottom types, wind statistics, solar radiation. These are all of importance to us in designing and operating the array. If possible, we're going to go a little further than that, even from these kind of straightforward things like understanding the bathymetry to things that are a little more like research projects to understand hurricanes, the potential for freshwater plumes from the Chesapeake Bay, the influence of the Gulf Stream. These will be things that we'll try to do in kind of the later phases of our site characterization. A kind of close cousin to site characterization is what I call water space management. We're going to be in an area that's very busy. We're going to be one user of many water space users. And Derek has taken the lead on this and done a first draft assessment for things like shipping lanes, seafloor cables, shipwrecks, wind farms, Navy operating areas, other factors, so that the notional designs that came out of the innovations lab, although the group was very good about being aware of those things, but not in detail. And so we need to get detailed about water space management, and we're starting down that road. There'll be more to it. I think an example would be additional siting factors that we haven't considered yet in this preliminary design. We might want to get close to a place where there are methane seeps on the slope, but we might want to stay away from a place where there are cold water coral communities, and they might be right next to each other. So there's more work to do there, but we do have a first cut. And also what we need to recognize is that as long-term occupants, we need to worry about environmental compliance, permitting, potentially NEPA submissions and approvals. And so we have started a regulatory study to establish these requirements and what the process is going to be. We've engaged a consultant for this. We're not subject matter experts in this area. So a group called Tetra Tech has been engaged. The kickoff was just a few weeks ago, and we expect about a 3-month effort there to, it's a scoping problem right now. We're not filing for permits yet. We're trying to understand what it is we're going to have to do. We're not going to file for permits until we have the designs at a more finalized state. Engineering assessment, after you get all this stuff lined up, the site characterization, water space management, and some understanding of what instrumentation might be desired, you have a need to potentially redesign the moorings, or at least tweak the mooring designs. Some changes will be more extensive than others. We know we have to change the water depths for certain locations, the designs for different water depths, and we have to accommodate potentially different sensor payloads. So with a new mooring design, then you want to go and put that mooring virtually in the environment. So you do design studies, computer simulations to assess the mooring performance, and you need to know the wind, the waves, the currents, and that's where the site characterization comes in. This will probably be an iterative process, right? If you redesign the mooring for shallow water with lots of sensors and you put it in your simulation and it sinks or moves or hops around or doesn't work, you're going to have to go back and try again. Finally, we have the opportunity to do a modeling assessment, which is really nice. We can work with a team that has a high resolution model of the area to assess, the way I think of it, as the array suitability to the environment and the science goals from the modeling perspective, right? Models have limits, just like the observational data we have has limits, but having this additional perspective that we didn't have for the New England Shelf Pioneer arrays is really nice. So let's shift to some more detail on some of these things that I think are going to be of interest to the audience. So what are the science themes? As I said, we were able to group these into some kind of high level themes. One of them is the dynamics of shelf slope exchange. This is interestingly reminiscent of one of the high level themes for the New England Shelf Pioneer array. Wind forcing, frontal instability, Gulf Stream influence, and things like the confluence of all these different water masses, which you see in the figure over to the right, which comes from a diagram from the Peach program, are all part of this dynamics aspect. Another really strong theme was biogeochemical cycling and transport. The kind of things we're talking about cycling and transporting are carbon, nutrients, and particulates. And what's the kind of driving towards the science here is not necessarily just the transport of these properties, but the ecosystem response to that. And the goal or the challenge put in front of us was to understand the ecosystem response from primary production all the way up the trophic levels to marine mammals, which I think is going to be pretty tough, but we will see what we can do to accommodate that by enhancing some of the instrumentation and trying to design the array correctly to do that. There was also the third kind of category where things were interesting was in extreme events like hurricanes, freshwater outflows, which I mentioned before. So these science themes then led to an array design. So the science themes drove the array design. We got a lot of consensus about design concepts from the Innovations Lab participants. And our job as the operators is to kind of assess this and refine it so that it's doable, functional, comes in within budget, and we can maintain it over many years, right? So our goals are to assess the utility of these plans relative to the science questions that I just showed you, to optimize the use of our existing inventory. I'll tell you what that is in just a second. To ensure, as I said, that it's feasible and that it operates within the current budget. As we understand it now, the budget will not change. I mean, we know that the fractional budget associated with Pioneer won't change, and we don't expect at this time the overall OI budget to change either. So let's talk about what these array elements are that we're trying to utilize to the extent that we can. There are basically, I guess, four major elements to the Pioneer array. One is the coastal surface mooring you see on the far right, CSM, the coastal profiler mooring next to it, CPM. These form a really nice observational pair you can get from air-sea interface all the way down to the seafloor between the measurements on those two moorings. There's also going to be some shallow moorings, which I alluded to, that will be of a different design. Neither of these two designs you see here are really quite applicable to 35 meters water depth. So we need to think of how we're going to do that. There are also gliders, which you see on the bottom of the figure, and AUVs, of which we have two Remus 600 based AUVs. So these, as I said, the details of how those will operate, it's not quite been fleshed out yet, but we have made progress on the moored array. So let's go there. The area of interest, as we've talked about, is southern MAB, offshore North Carolina, but north of Cape Hatteras. The moorings are going to be deployed in this kind of red box, the mooring box. Some notions of how they might be spread out are shown as the white circles there. And the mobile assets can operate certainly within that moored array region. They will maybe be even concentrated there, but they can also potentially operate further afield in that green box along the shelf and slope. So let's zoom in on that moored array. I have to start this slide with each talk saying it's preliminary, conceptual, notional. This is not that, don't try to figure out the lat lawns and decide that this is exactly where it's going to be. This is a representative, plausible design that fits most of the criteria, but I'm sure it will be tweaked when we go through the regulatory process and other things. So the components are the ones I just talked about. Surface moorings are shown as the circles, the profiler moorings as the triangles, and these newer, yet to be designed shallow moorings as the squares. And you can see that we've got an along slope array. This is notionally the 100-meter isobath, and you've got surface mooring, profiler mooring pairs, which is a really nice way to make the observations. Further offshore are isolated profiler moorings to get at the slope C processes, and then creating the east-west leg of this kind of sideways T-shaped array are the shallow water moorings. And the bar, this spacing here is about 20 kilometers to give you a sense of scale. The challenges, I've talked about most of them already. regulatory issues, moving into shallow water and attempting to accommodate as many instruments as we can from the recommendations of the Innovations Lab. So let's see, I think we're going to move into sensors. So how are these moorings going to be outfitted? The baseline is going to be the current OOI core sensor set, just to kind of make that straightforward. It's evolution, not revolution. We're going to enhance these, hopefully modify them, but we're not starting with a blank sheet of paper. We're starting with the infrastructure that we have and the core sensors that we have. From the Innovations Lab, we got a long list of instruments and measurement concepts that were really great, really fascinating, and in some sense were developed into a consensus by looking at which groups independently recommended the same kind of measurements. And so we were able to, based on that, come up with a kind of a short list that's more 10 to 15 range rather than 40. 40 was clearly too many for us to accommodate. And we need to squeeze down that short list a bit more. So we're in the process now of looking at that based on a variety of things we're going to use to refine it, such as the science, how applicable are these measurements to the science themes? Are the instruments proposed have a high level of technical readiness? Are they available commercially? How, even if they are highly attuned to the science themes and high level of technical readiness, can we operate them? Are they feasible to attach to the mooring? Do they work with the array design? And finally, even if they meet all those criteria, if they, for some reason or another, are very expensive, maybe very expensive to purchase or very expensive to maintain, we obviously couldn't deploy very many of them, or maybe couldn't deploy them at all. So those are the kind of practical overlays that are going to go on to the recommendations from the Innovations Lab. So I think this is pretty much where I'm going to end. There is going to be outreach and communication, obviously, throughout the process. Part of it is for us to do, which is to try to maintain and foster partnerships and collaborations. There's also our job to work through the water space management issues by talking to people, having conversations and presentations to the stakeholders. And then as communicating to you all, we're going to use the methods that are already in place for the program, such as the OOI website, the monthly newsletter, social media postings. Hopefully all of you have seen one or all of those at some level. And for example, the timeline I showed in the first or second slide was posted soon after we had it ready in September, and we're working on, as you can see, we're pretty much ready to post little blurbs on the science themes, and we can put our notional array design out there, and we'll keep trying to provide short, simple updates as things move ahead. And finally, meetings like this one and presentations of progress and status and available for questions and answers. So that's where we are now, and I think I will stop there, and I will stop my screen. And we'll go to the sort of panel concepts here, and we're ready to entertain your questions.
All right. Well, thank you very much, Al. That's great. And Lisa, those are great presentations. And hopefully we'll hear from Derek very shortly as we ask questions. So please, if you have a question, you can raise your hand, and we'll unmute you if necessary, or you unmute yourself and ask the question. I don't see, I do see a question that we could start with. And that was, so Al, I think this one might be best for you. So can you describe the goals of the modeling effort that you had mentioned?
Right, so with the regional model, there are some things we can do there that are not amenable to the observations. We're looking at historical observations, obviously NDBC moorings, the Peach project provided good data, there's shipboard data, other things. What you could do from a model would be something like take a particle seeding experiment, seed the particles within the moored array and run them backwards in time and find out where they come from. That might be a really good way to decide where you might want to run a repeat glider line to look at the sort of upstream conditions that are going to be impacting your array a week later. So That's one example. We can look, the models will have certain limits in terms of what processes they resolve, of course, but for the resolved processes in the model, we can look at correlation scales, time scales, spatial dependencies, and try to get a sense that our moored array and potentially mobile assets are actually resolving the processes we expect them to. So those are kind of two examples of how we'll use the modeling results.
Very good. So anyone else, please raise their hand. Oh, look, James Etson has a question. I was curious, Al. So there are obviously some similarities between the two sites and some of the processes you're going to be investigating. I wanted to get your take on what you see as the, you know, the sort of different focus that's going to be brought into play with this new deployment in the Southern Mid-Atlantic Bight versus the Northern Mid-Atlantic Bight. And maybe Derek, if you have a chance to sort of comment on what you see as ways that we're going to use instrumentally through sensors and such to investigate those processes.
Yeah, so when it wasn't just me, of course, it was a whole group of us, but when we envisioned New England Shelf Array, we thought that the processes were going to be focused on instabilities of the shelf break front. And it was humbling and also really kind of fun to be shown that that was pretty much totally wrong, and that the processes were much different than the dominant processes were different than we imagined. So this will probably turn out in 5 years totally wrong as well. But I think that one of the big differences is that we will not see the direct impact of Gulf Stream eddies at the shelf break. I'm sure hoping that's the case. I think that the Gulf Stream in this region is going to stay offshore of us, and we're going to be more focused on this really complex recirculation regime, which kind of was shown kind of really notionally in that peach diagram with all these different water masses converging. And then, so that's one aspect I think is different. And the second one that we think will be intermittent and more of an event-like process, but the potential for strong influence from freshwater outflow from the Chesapeake Bay. We chose the New England Shelf Array on purpose to be far away from riverine influences, which seems to have held true. But this one is kind of chosen for the opposite reason. There's a sense that there will be intermittent significant impacts from freshwater outflow. So that would be two ways that can be proven wrong in the future about how it's different. Well, Derek, you want to talk? You can pitch in on, the kind of sense of going to biogeochemical sensors and some of the other instrumentation that was suggested by the Innovations Lab group.
Yeah, I think we're going to have a little bit more of a focus on biological, or we're going to assess the instrumentation and include things like the potentially the flow cytobot, a few other different types of sensors. We're taking the lessons learned from the original location and looking at additional measurements we can do along the, within the water column on the riser of the different moorings. For example, adding instrumentation in the, I'll call it the gaps in the riser between, say, for example, looking up from the near surface instrument frame, or adding some spears with some additional instrumentation mid water column to add to our measurements. We're also looking at in the downtime how we use our mobile assets to fill in gaps better, and are there different vehicles that we can potentially look at that maybe provide higher resolution data. Can we operate from the beach because we're on a much smaller shelf, which would allow us to potentially put vehicles in the water more often. We won't have to potentially rely on small vessels or vessel turns to do it. So we're looking at some potential innovations in the infrastructure along with the move.
Derek, that's excellent. Thank you. And I'll invite also those of you who attended the workshops and don't necessarily have a question, but have some comments they can make about all this. Please feel free to raise your hand as well. Now's your time. We've got the experts in the room here. I'm looking. Oh, come on, there must be someone. For those of you who have joined us today. Oh, we have, well, Darlene.
Jim,
Please go
if I
ahead.
may.
Yeah, yes.
I'm wondering if people get off the line here and have suggestions for Al and Derek. How would Al and Derek like to be communicated with? Can people just pick up the phone or send you an email? What's your preference?
I think email is fine in general. We can usually get back to you within not too long of a time. And the OOI help desk is another option. We actually all see that as well. I know for me, the help, when I'm trying to send something into a help desk, I always figure it's just, a fake and there's really nobody behind the curtain. But we do really look at that stuff. So you can use that. Yeah, so those are perfectly good ways.
Very, very good. I should have let Glenn ask his own question, but Alexander, do you want to ask your question? Unmute and ask. If not, I can, oh, there he is. Go ahead, Alexander.
Yeah, I was just wondering, what is the planned approximate maintenance schedule of the new moorings? And are you guys going out from Oregon Inlet as your base?
Yeah, that's a good question, Alexander. First one is that we will maintain the same nominal schedule of 6 months turns for the moored array. That's worked pretty well. I don't know that we've ever quite hit 6 months, but we get 5, we get 7. We're in the ballpark, and that's what we need to do in order to maintain the higher quality for the sensors that get biofouled and maintain the sampling levels, the sampling frequency we want for instruments that have batteries. So that's really the drivers for those. And then operations for the major moored array turns, we should get a picture in one of these talks or something of the deck of the ship when it's loaded with the gear. It's a lot of equipment, and you cannot do this on a small regional vessel. You need a big UNOLS ship with lots of deck space, ability to handle 4 or 5 containers and winches and all that, dynamic positioning and lots of other stuff. So we expect to operate the moored array turns from Woods Hole, at least nominally, until we learn that there's another suitable UNOLS vessel that can do the job. But it's got to be a pretty capable vessel to do it. There is potential for local efforts for things like glider turns, and in particular for things like unplanned glider recoveries. So there is potential for a local component to this, but it's not planned as a local operation, if that makes sense.
Yeah, and just the mobile asset operations, it's the glider ops are typically every 60 to 90 days, depending on, depending on what happens with the vehicles, if they foul or if there's an issue mechanically, we may go out more often to recover vehicles before they're lost. And then we'll also have right now at the current Pioneer location, the plan is to have AUV cruises approximately every 2 months. So that's what we're planning for right now for the new location. But as we get into the modeling a little bit more, that glider operation, that AUV operation may change, may need to be updated.
Great, thanks. That's what I wanted to know.
Thanks, Darlene. Yeah, that's the image I had in my mind's eye.
Wow,
That's for a global cruise, not a coastal cruise, but the concept is pretty much the same. It's jammed with stuff. And is that the Armstrong, I think, Darlene?
Yeah.
Yes, it is.
Yeah, so, and even like that, those boxes with the yellow spheres, those are 20-foot containers.
Yeah.
There are actually another set of 20-foot containers underneath those two 20-foot containers. So anyway,
Yeah, to give you an idea of what the cruise looks like, it's typically 2 legs of about 10 to 11 days each, one being for surface moorings, one being for profiler moorings. The new location will be a little bit different because we'll also have the new shallow water moorings that will have slightly different configuration from both those, from the surface mooring and from the profiler mooring. So we'll have to fit that into our schedule as well. But yeah, there's typically 2 legs that we split scopes on.
Thank you.
We're looking, last chance, any of you out there. And I would ask you to keep in mind that throughout this week, the virtual booth will be open, essentially will be open for business from sort of 3 to 4 all week. And so we encourage you to register and check in. There'll be more detailed talks. I know there's going to be I believe there's lightning talks, which are always very interesting, people using the data. We had lightning talks during the town hall, but of course we had to really cram a lot into that town hall meeting. So we should have plenty of time for during those lightning talks to ask questions of the people presenting. So I believe that's Thursday. But throughout this week, we're gonna have some really interesting stuff. Maybe I'm not sure if Darlene can confirm this, but we will have a group that talks about the biogeochemical sensors and their interests in just Pioneer in general. Is that, Darlene, is that happening?
Carbon and pH.
Carbon and pH. What day is that? I'm sorry.
Tuesday.
Tuesday. So that'll be tomorrow. That should be a really interesting talk. So I'm here saying going once, perhaps going twice and 3 times. All right. Well, I think that's it. We've gotten up to about quarter up. That's great. And I hope people are enjoying the Ocean Sciences meeting. I was an organizer, and so we got thrown a curve there last fall that this was going virtual. And there certainly are plenty of oral presentations right up to 9 p.m. Eastern time. But I hope people take advantage of the Ocean Sciences meeting. Let's hope that this, in 2 years' time, we are together, right? I think all of us would like to see that. And in 2 years' time, we're going to have made a ton of progress on the movement of the Pioneer Array to the Southern Mid-Atlantic Bight. I think we may be very close to having many things finalized and be putting things in the water. So with that, I thank you for attending. And I think we'll see you hopefully tomorrow at 3 p.m. All right. Bye, everyone. Thanks, Al.
thanks, Jim.
Thanks.